Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 42 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Nano. I'm going to need you to pour yourself a nice cup of hot coffee. That's right, we'll be drinking hot coffee today. I'll admit this morning I got up, I made myself a nice huge mug of iced coffee. I got in the car and I drove off without it. That's pretty sad. So today I will be enjoying hot coffee. You guys can have hot coffee or cold coffee, whatever you prefer. I'm going to need you to also get out your Jetson Nano gear and get ready to learn some cool new stuff. As you're getting out your gear, as always, I want to give a shout out to you guys who are helping me out over at Patreon. You are keeping me in premium coffee beans and you are keeping this great content coming. Really appreciate your help. You guys that are not helping out yet, look down in the description of this video. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's talk about what we are going to learn today. What we are going to learn today is a really slick lesson. We are going to learn to find and identify faces in live video. Is that not cool? That is really cool. And that's kind of like what we've been building up to for 41 lessons. This is kind of like one of our first real examples of an artificial intelligence network where we're going to train the system and then we're going to use it in real time on live video. So go ahead and get your gear out. And I think probably I should get out of your way before I forget to do so. I need you to go over and open up your Visual Studio Code as such, and we're going to come over here and we are going to open up a fresh new program in PiPro, and I believe we are working in Face Recognizer, and we are going to create a new file, and this looks like program number 5 along here, so I'll say Face Recognize, and then I want to put like dash live video, if that's not getting too long, in .py, just so that like 5 doesn't mean a lot, program 5 doesn't mean a lot, but if I tag it also with live video, I kind of know what I'm doing. And indeed, the .py is important. Okay, just a reminder that this is a follow-on lesson to the last lesson, because in the last lesson, I showed you how you can train this thing so that every time we run it, we don't have to train it. And we did this program called Train Save, where we loaded in the images, or what we did was we put the images in a folder, then we go to that folder, we load them one at a time and encode them or recognize them, and then we save that training set in a pickle. Okay, so this simple program right here will train your network. Now, since I've been playing around with images, it would probably be smart for me to go ahead and train it. So I'm going to go ahead and run this before we do anything else so that my system is trained on my latest set of images. Also, I showed you where you could get images, where you could download the same images that I'm using from GitHub. So I'm going to run Python file in terminal. I'm going to enjoy a little of my wonderful coffee. And we're going to let that thing get trained. How are you guys doing? Are you guys still in lockdown? I don't know. By the time this video is actually released, maybe a few of maybe they've kind of loosened things up. But I know that as of right now, when I'm making the video, a lot of you guys are kind of locked down pretty tightly, and so hopefully you're enjoying learning something cool during this time. Okay, we are learning here. Our network is learning. What you'll find is the larger the image, the longer it takes to learn it. So some of these kind of slow ones are because they're because it's a big image. So we'll give it a chance. And then we will start coding. In fact, while that is running, I can probably come over here and go ahead and start coding. So let's go ahead and do that. Okay, we're going to start just from scratch here. A lot of this is similar to things that we did like in lesson number 40 and 41, but it's always good to review. So what do we need to do? We always need to import face recognition. That's good. We are going to need to import what else? Import CV2. Also, remember how we kind of walk through that directory structure to do the learning? What library does that? Class. What library? Bueller. We do OS. Okay. And then we also remember how we dumped everything, all that data with a pickle. Well, now we're going to have to load the pickle library so that we can read that training data. So pickle, and then print, and then we're going to print our cv2 _ version, and we're kind of like on 4.1.2. I am going to go ahead and run this just to make sure all my libraries and everything are set up right. I like to run things as we go along, because if you write a bunch of code, then you try to run it and there's some strange little error early on. So I like to kind of run it as I go. Just a little pro tip there. And we remember that face recognition is a very big library, and it takes it a second to load that thing. Okay, looks like that ran very well, and we are in fact on OpenCV version 4.1.1, which is a really nice one. Okay, let's see here. I believe that we are going to need to set up our arrays to hold our training data. We're going to call that encodings, and so that is the encoding for different faces that we're trained on. We're going to read into this encoding, but we're just going to go ahead and create it empty. And then we also have the names that go with those people that we're trained on, and we're going to call that names. Now we need to read those in, so we're going to with open. Okay, and where did we save? Do you remember where we saved that pickle? We saved it as, where is that? We saved it as train.pickle. Train.pickle. So that's what we want to read. We want to read train.pkl. And then how do we want to open this? Well, we want to read bytes, RB. Does that sound good? All right, and then we want to open, option, that should be open. Okay, and we want to open that as F. You can open it as whatever you want, but I'm just opening it as F, as in file. Okay, now I'm going to read that data. So I'm going to first read the names. Why? Because we saved names and then saved encodings. So we should read names, read encodings, because those orders will matter. And how are we going to do that? We are going to do that with a pickle.load. And where do we want to load from? F that we just opened, okay? And then we have encodings, and we need to open that with a, or load that with a pickle.load from F. And that's really all you got to do. We should have our training data now. All right, so you guys know how to launch a camera by this time, right? So you launch whichever camera you want in whatever way you want. The easiest one for me is I'm going to be using my webcam. So I'm just going to say cam is equal to cv2.video capture, and then that's going to be 1 for me. It might be 0 for you, or if you're using the Raspberry Pi, you got to use that camset command. But by lesson number 42, certainly everyone knows how to do that. Okay, so we've got the camera loaded up. Now we're going to put all this in a while loop. So this is going to look a lot like what we did last time, but last time we didn't have a loop. You just ran out, grabbed a picture, recognized it. Grabbed a picture, recognized it. Or maybe we had a bunch of pictures in a folder and you just walked through them using that os.walk command, os.path.walk command. But here we're actually going to be grabbing the frames from the camera. You guessed it. So we're going to do a while what? While true is true. How long is true? True. True is always true. So this is kind of a infinite loop. We are going to go out and grab the frame, but remember when we do a cam read, it returns 2 parameters. We don't need the first one, so we'll just put it in an underscore, comma, and then the one we want, which is frame, and then that is going to be equal to cam.read. As simple as that. How does it know where to read? It reads from cam, and we define cam up there. So this should make sense. Okay. Now let's go ahead and I think probably what we should do is let's go ahead and do a conversion, because remember this reads in BGR, and the frame recognition software operates in RGB. So let's go ahead and do that conversion. I really don't know if it's necessary or not, but let's do it. Let's say frame is equal to cv2.cvt color, convert color, and then what do we want to convert? We want to convert frame. And then how do we want to convert it? cv2.color, all uppercase, underscore, and then BGR. That's what we read it into RGB, just so that we get the color space. Ah, I touched my face. I got to stop doing that. I got to stop touching my face. CV2 color BGR, where we are in OpenCV, to RGB. which is what the face recognizer wants. I should probably give this a different name, so I'll call this frame RGB. Frame RGB is frame, okay, and so now frame RGB is the one that we should actually be working with. Okay, and we go BGR to RGB. That all looks pretty good. Okay, now we have a frame. It's in the right color space. What do we want to find? We want to find the faces. So face positions. Face positions. How do we find the faces? Well, we use our face, and if I get rid of this up here, it will make all of our lives way easier. Right now you can see things a lot better. Okay, how do we do that? Well, that is our face recognition, and then dot face underscore locations, right? So we do face underscore recognition dot face underscore locations. And then where do we look? Well, we look at frame RGB, right? Frame RGB. And then I'm going to go ahead and put a model in. Let's see, model is equal to CNN. All right, the default model is the HOG, H-O-G, and H-O-G runs pretty fast, and so like if you were trying to do this on the Raspberry Pi, the HOG is a simpler model for finding faces, but it's slower. Okay, the CNN is a much more sophisticated, much more accurate face finding algorithm, but because we have the 148 or whatever parallel process on the Jetson Nano, we can use CNN because we can do this in parallel. So this is one of the advantages of having the Jetson Nano. You can run these commands that require the parallel processing. So this is where we're really getting into the advantage of using the Jetson Nano. We get the best face finder and it runs quickly. Okay, so now let's see, we've got frame RGB. All right, and you know what I am going to do? I'm going to just run this just to make sure here that there's another parameter for that face positions, and I want to make sure that it doesn't need it for that face locations. Looks happy so far. Okay, line 18. Didn't like line 18. Misspelled color. Oh, did you guys catch that? See, the nice thing about running this as we go? I don't have my quit keys in there, so I'm going to have to probably just crash it. Okay. But it's sitting there running, and it looks happy, so we'll kill it. All right. So that looks good. So now we have found the position. So now what do we want to do? We want to see if we can identify all the faces in the picture. So how are we going to do that? All encodings is equal to face under, I guess I should explain what I'm doing here. Okay, we have a picture. We know where the faces are. Now what I need to do is I need to go to each one of those faces and encode it. Okay, so I'm going to do face recognition dot face underscore encodings. Okay, so I'm going to encode what? Well, I'm going to encode the frame. So that was frame RGB. That's where we're looking. And then where all do I want to look at face positions, right? Now that that should make sense, because frame is the picture that I'm looking in, frame RGB, and where am I going to look? I'm going to look in those locations, and then for each one of those locations I'm going to create an encoding. So if I have 3 faces, I'll have 3 encodings. Okay, this should be familiar to you from the last few videos. So now I've got all my encodings. Now I need to step through each one of those found faces, and I need to compare it to my training data, my encodings. So to do that, I need to step through it. And what do we want to step through? The rectangles. And darn it, remember how this how face recognition sort of gives a real strange order. Instead of top left bottom right, it does top right bottom left. And so we've got to remember that, because it's not using the same order of those coordinates as OpenCV does, but it's going to return us top and then right and then bottom and then left. So we get these in the right variables. So we're going to step through that, and we're going to step through face underscore encodings. Okay, so it's going to step through the different locations, and it's going to put the location in top right bottom left, and it's going to put that particular encoding in face encoding singular. And where do we step through? Well, we got to do the zip, because we're stepping through 2 things. We're going to step through face positions and all encodings. Okay, face positions is where the face is in that frame, and the all encodings is going to have the corresponding encoding. So this is the new frame with the unknown faces, where they are and what their encodings are. So we are stepping through those. We're stepping through each one of the found faces would be a good way to think of that. And we've got to remember our friend the colon at the end of that. Okay. And I really don't like it when you can't see the whole line. But now it might be that it doesn't recognize anyone. So in case it doesn't recognize them, we're going to go ahead and give it a name of unknown person. Okay. Now, if it does know the person, it will change this to who it is, but we'll just put it there in case it doesn't find out who they are later on. It will have a name. Now we need to see if we can find out who they are. So we need to compare what? We need to compare that face encoding in that box that we're in right now at the first time through the for loop. We need to compare that to all encodings. So we need to find matches is equal to face recognition dot, what are we going to do? Compare faces, and between what and what? Well, the encodings, which is all of the training data, everything that we know, and then we're going to compare it to this particular one, face encoding. Okay, so face encoding is the present unknown face in the frame that we just grabbed, and we're comparing it to encodings, which is all of our training data. and we're going to look for matches. Now matches will return an array of true and falses. So it'll just say false, 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 true, false, false, true, false, true. It'll put a true in the places that unknown matches one of the trainings. So this will kind of give us a thing that we can key on. All right. So what we can say is if there's any trues in that array matches, so if it finds true anywhere in there, then that's our guy. Now we're kind of cheating here because what we're doing is we're just grabbing the first one. All right. But if we really wanted to do it, we would kind of want to step through all of them and see, does it match more than one person? And darn it, I just touched my face again. Man, I'm going to get this thing if I'm not more careful. Okay, so if there is a true in matches, then we got to figure out where was that true in matches. So what we got to do is we got to say first underscore match underscore index is equal to matches dot index dot of true. Okay, so how does that work? I've got my matches, and because I'm here, you know that there's true somewhere in that list. I want the position of where that true is. I want the index of where the true is. So I just say find in matches the index of where the first true is. And then I'm going to put that in first match index. So now I know which slot in that list of encodings matched. Well, now what I want to know is, what I really want to know now is, I want to know what name, and the name will be in the same position, but just in that other array, right? And so here I could say the name of the person is going to be, look in that names array, and then look at that index that we just found, first match index, first underscore match underscore index. Now I know who it was that was in that first location of that image I grabbed from the camera. Okay, grabbed the image from the camera, I found all the faces in the image, and now I know the name of the person in here. But if there wasn't a match, if there was no trues, if there was no true, I would just be left with unknown person. I hope this makes sense to you. Really, it's kind of simple. If you're not understanding this, just kind of go back and watch it again. Okay, so now what do I need to do? I need to box him. So I'm going to say cv2.rectangle. Okay, now I'm going to show this, so I need to go back and not work with frame RGB. I need to work with my original frame. So I'm going to put it on my original frame, and then where do I go? Left, top, and then comma, bottom, right. Sort of what makes sense. But these will be right because I read them in the order that the face recognizer is going to give them to me, and then I put them in the kind of logical order here for the OpenCV. Okay, so now I've got that, and now we need to give it a font, and up here I better define a font, huh? So I better say font equals cv2.font underscore. I got to go back and take a glance at this. Hershey Simplex will work. Font Hershey underscore Simplex. Okay, Hershey underscore Simplex. Now when I put that font in, it will know what it is. And now I got to give it a color. So let's just go 0, 255 should put a red box on it. And the width of the box, or the weight of the line on the box, should be about a 2. And that should look pretty good. Now what we're going to need to do is we're going to need to put the name on it, label it. So we're going to do a cv2.put text. Good news is we know who it is. Where do I want to put it? I want to put it on the frame. And then what do I want to put on there? I want to put name on there, which we just found. And then you want to start at left, okay, and then comma, top -6, because you don't want the line to go through the text, and therefore you want to go to a smaller Y value to move that text up, so it should be right above that boxing rectangle. We scoot it up just a skosh. Okay, so that's where it's going to be, left and top -6, and then we will put in our, I should not have put a font in up here. Were you guys screaming at me? That was not the right place to put that. Okay, and then here we're going to put it down here, and this is going to be font. And then how tall do we want it? About 0.75. And then let's give it a color 0, 0, 0, 255. We'll do it red. We probably should get more clever about what color to make it, because it seems like there's all these different background possibilities. And when we just use a single color, if there's kind of a reddish background, then the text doesn't show up very well. So at some point we should probably do a little bit better on that. But that looks good. So we have given it a color. That all looks good. Okay, now after we have stepped through all the different recognized faces in the frame that we grabbed from the camera, we need to go ahead and do a CV2. This is not in the for loop. It's after we've added all the boxes on all the faces, done all of that. Then we're going to drop out of the for loop and do an IM show. And what do we want to show? We want to show our picture for the name of the window, and then we'll just do frame. Okay, and now we want to be good and do a CV2.move window, and what do we want to move? Picture. And then where do we want to move it? We want to be good and put it up out of the way, so we will put 0, 0, and everybody should be happy. We just got to remember though that we've got to give it a way to break out, so we say if CV2.wait key, we'll put a 1 in there, if that equal the ord of Q. So that means if we see a Q, we will what? Put your colon there. We will break, and then we've got to come all the way out, because we're breaking out of that if all the way back here, and we will cam.release, and then we will CV2.destroy all windows, like that. Okay, let's hold our, well, we can't hold our breath because that one library takes too long. Oh man, you guys have been frozen there, haven't you? Okay, let me see if I can fix that for you real quick. How long have I been frozen? There we go. Sorry about that. So you're just going to have to live with the frozen me, because I don't want to go back and remake this whole video. Hopefully it wasn't frozen on you too long. So we are going to destroy all windows. All right, so that looks pretty good. So we're going to run this thing and see how many mistakes we made. So right mouse click, run Python file in terminal. Takes a little while, but it will be well worth it. Okay, looks like that it has loaded up the training data, and it is getting ready to fire off the camera. If we have a little luck, we will fire off the camera. It's making me wait a very uncomfortable amount of time. So let's see. Not sure what. Maybe going out and loading that thing. What is taking so long? Okay, float object is not callable. The CV2, ooh, put text, I didn't put a comma in there. Did you guys catch that? That will get you every time. I'm still not sure why it didn't. Oh, it hadn't gotten to the IM show yet. Okay, run Python file in terminal. I'm not sure why this is so slow, but we'll look at it. It should pop up a window, and then we will figure out what is going on. This is really exciting to me. It just is so many different places we can go with this. And the neat thing is you're not downloading someone else's library, you're training it yourself. And all you got to do is go in that known folder and put the people in there. Whoa, string is not callable. Oh, another comma. Man, I am missing my commas. Are you guys catching that and screaming at me? Okay. Hopefully this time we'll get it to work. I am getting dangerously low on coffee. I might have to excuse myself in a minute and go make me another coffee. But I'll just power on through for right now. Okay, looks like it's going to try to run. Line 30. An integer is required, not a tuple. Oh, move window. Is that a z? Yeah. I always get confused. Sometimes it wants a tuple, like a tuple, open parentheses, x comma y, close parenthesis. That's a tuple. Or sometimes it just wants comma x comma y. And I did not remember that one right. Okay. I really don't know the difference between the subtleties between a tuple and just an array, you know, the round brackets versus the square brackets. Okay. Let's hope it's happy this time. I really think it should be. Hopefully you guys can see that little video window pop up here pretty soon. Okay. It popped up. Is it going to give us a picture? No, it's not going to give us a picture. Okay, org. Org. No, it's not our org. It is our ord. Our ordinance. The ordinance of Q. All right. Those are kind of little mistakes, so hopefully the whole thing will run. Hopefully the whole thing will run here. It did seem like it took a long time. It seems like it might going to be running kind of slow. So the first thing is, does it work? And then if it does work, can we speed it up? Okay. It really bugs me, this G-streamer warning. I have not figured out how to get rid of that yet. We have a blank window. Okay. Now, what you can see is it recognized me. Okay. Look at that. Boom. I probably have an error somewhere in my top right, bottom left, because that does not look good. Okay. What's the good news? Knows who I am. It's almost working. What's the bad news? The rectangle is the wrong size and it is painfully slow to the point of almost crashing. So let's see if I can Q out of it. Sometimes it gets so slow that your Q button doesn't even work. Okay, there, that worked. Okay, so we did CV2 rectangle. We want left top. We went, it goes top right, bottom left, top right, bottom left, left top, bottom right. This is confusing me why that doesn't work. I'm on my frame. I'm on left top. Oh, I wrote this backwards. Did you guys catch that? Right. Bottom. Okay. Do you remember that OpenCV kind of uses X comma Y, and so X is left and right and Y is top and bottom, and the face recognizer does top right, bottom left. OpenCV wants left top, right bottom. Okay, but if we do this way, this should actually work. I think this is going to work this time. It's still going to be slow, but I think it's going to kind of recognize. And then what you can see is, what did it look like to you guys on speed, it looked to me like about 1 frame a second. And that's cool, but you know, we really got to have the video running a lot smoother than that, right? We got to have it going faster and smoother than that. 1 frame a second is just not acceptable, and we should be able to get it to do better than that. Okay, I think that is working now. Now what you see is that this face recognizer kind of crops the face pretty quickly, but let's see if I'm here. 1001, 1002, 1001, 1002. I would say maybe we're getting about 1 frame a second. So why are we happy? We're happy that it's working. We're happy that it looks like it's working pretty well. What we're not happy about is we're not happy about how slow it is. So let's quit out of this thing. Okay. Let's see if we can quit out of this thing. Again, when the frame rate is this slow, it's almost like you got to kind of hold the Q button down, and sometimes it will actually crash on you. Okay, we're just going to have to kill it ugly with the trash can. Kill it ugly with the trash can. Sometimes if you kill it ugly, you got to go kind of stop your Visual Studio Code and start it again. But hopefully that won't be the case here. So let's see how we could make this thing run faster. Well, the problem is the bigger the image, the longer it takes to find all these things. So once we get to this point, let's see if we have this, let's see, where we get this, we read the frame, okay? So we have frame, and then we convert the frame. But before we do that, let's make the frame smaller. Okay, now we're going to keep the original frame, but we're going to be doing our artificial intelligence and our recognition on a scaled down frame so we can go a lot faster. So what we're going to want to do is frame small, and what we're going to do is we're going to say that CV2, do you remember how to resize, and then frame, and then we want to put the tuple, the upper corner 0, 0. Okay, and then we want to give it the ratio, the ratio that we want to scale it by. So I'm going to say fx, the x ratio, the scale factor in x is going to be equal to 0.33, and then the scale factor in the y, I'm going to be equal to 0.33. Okay, now what is the trade-offs? The more you scale it down, the faster it's going to go. But the more you scale it down, the bigger the face it has to have to recognize it. So if I scale it down to 10%, it will still work, but the face is going to have to be right in the camera. Okay, so you've got to kind of play around with this. If you just made it half, it would recognize all the faces and recognize the small faces, but it would still be pretty slow. I'm going to try about 0.33 and see if that works. So now I've scaled it down. But I got to remember now that after I'm done doing the face recognition, I got to scale it back, okay? And where I have to do that is I've got to do that before I start drawing rectangles and that type of stuff. Because remember, now the top, right, bottom, left are going to be based on those scaled down numbers. You know what else I better do? I better change this. So this is frame small, okay? And then what I better do is I better convert frame small to frame RGB. Okay, I forgot that if I am going to work with frame small, then I've got to take frame small and I've got to put that then into frame RGB, and the rest should be right. Okay, but now before I do this top right, bottom left stuff, I better scale it back up. So now I've done the heavy lifting. Now I can go back to my original scale so things will match. So top is equal to top times 3. Right equals right times 3. Bottom equal bottom times 3. And left equal left times 3. So let's see if this will run faster. Okay, let's see if it'll run at all. Let's see if we haven't broken this somewhere along the way. I'm having a lot of fun with this, guys. I really am. I really like that we can kind of write it from scratch and do our own training and not have to just download someone else's. Okay, boom, look at that. This is pretty darn snappy. Facial recognition. Paul McWhorter. Boom. Do you see that? All right, look at that. This is pretty snappy too. Let's see how small I can get and have it still find me. Okay, that's pretty good. Look at that. That is pretty good. Now what you can see is there's a point that my face will become so small that it doesn't find the face, right? Because we've taken this face and we've scaled it down a third, so you finally get to where it's not going to find the face. Okay, so if this were normal times, where we weren't under quarantine, I could parade a bunch of my posse in here and I could show you that my boys we could recognize, okay? But my posse can't come today because we are practicing social isolation. But look at that. You see, that is really, really, really doing a good job. So let's see if it will work on other things. You're going to have to let me think about how to do this. This could be interesting. How am I going to be able to show you both things? Let's see. I might have to play around with this a little bit because I can show you. Yeah, that's my lovely wife in our African home making a delicious meal. All right. So let's see. I can show you this. Okay. But now. Okay, I know what I need to do. I need to come back over here. And now you can see what I'm just basically doing is I'm just pointing the camera at the screen because Donald Trump's a busy man. Plus, he's practicing social distance and he's not able to come in and appear live on this particular time. Okay, but look at that.
Legislation to deport gang members.
Boom.
They voted for sanctuary cities.
Look at that. All right, I'm going to call that a success. Okay, and then let's see if I can move over to another one. And let's take a look at this. All right, look at that. We've got Mike Pence recognized, an unknown person. We didn't train on him. And then Seema Verma. And so we're getting facial recognition. Giddy up. Do you see that? Let's run this thing. Giddy up. Look at that. Let's move it over here. Oh, Dr. Burks. Look at that. That is doing an amazingly good job, if you ask me. I'm very happy with that. The press. Non-human life forms. You see, doesn't even recognize them as human. Dr. Fauci, boom! Look at that. Is this cool or what? That is really slick, if you ask me. Okay, let's try one more. Oops, I should probably stop that. Okay, let's try this one. See who we got in here. Oh, that's Fauci again. Let's see. Okay. Yeah, I want to show we got Dr. Burks there too. Now, at this point, this woman's face has gotten a little bit too small. Okay, her face has gotten a little too small, so if I kind of move it closer, then it will get her. But you can see, again, it's that trade-off between how big, how much you scale it down and how fast it is. Okay, let's see what happens here. Okay, we're back to an unknown person. All right, guys. I think this is just super, super cool. Are you all enjoying this as much as I am? I am just having a whole lot of fun with this. And really now, all you got to remember is, let me quit out of this at this point. Okay, what you got to remember is you've just got this very simple program that you train with that we developed last time, where you basically just walk through your known image folder. Okay, and so we will come over here to PiPro, and where did we put that? We put it in Face Recognizer, Demo Images, and then these were my known faces. Now you can put whichever known faces that you want in here, and it will train on those. What you need to do is you need to make sure that when you do this, that you put the person's name as the file name, and that's basically all you need to do to train it. So what would be really cool is, since you're there with your family, train on your family and then see how well it works and play around with it. I wish I had live people in here and could have done that for you, but if you're at home, you can train on and then recognize your family. And so what I want you guys to do is, your homework is, whoever you have in your domicile, train on them and then play around with it, and then let me know how it works. Okay, I want you guys to kind of train this on your own people and then let me know how it works. This has been a lot of fun, and we're going to continue with more lessons in this series. I hope you're enjoying it. Again, really appreciate you guys who are helping me out over on Patreon. If you guys have not subscribed, go ahead and subscribe. Also, this is cool stuff. Share it with some other people. See if you can get some more people playing around with this series. I wish we had a few more people learning this stuff, because it is a lot of fun. Okay, Paul McWhorter from TopTechBoy.com. I will talk to you guys later.